Okay, friends, we're back. So part 2 of acid-base indicator. You look nervous, kid. What are you staring at over there? You're just looking? Sure. Waiting for something to do a trick?
No.
No? You sure? 100%? 105? 110? Okay, so anyway, so we've got our indicators, and we got a few more things that we want to use this time. And so we'll pull out 4 more. I'm going to get a couple things a little bit closer so we don't have to reach quite as far across. A few things in here might be a bit of a surprise, others not. So, Al, why don't we do the lemon juice first? And so we got 4 cups again, and let me back these up. Why don't you do the one closest to you?
Okay.
And you know what? Why don't you give this a shaky shake first to make sure it's all dispersed and mixed? That's good. You know, and give it maybe like, fill it up to like my finger.
Okay.
Ooh, that's good right there.
Okay.
That's a pretty one. So lemon juice, not surprisingly, what's the acid in lemon juice, do you know?
Citric acid?
Well, hey guys, just so you know, we did not rehearse this before going on.
That's because of what they put on sour gummies.
Okay. What do you want to do next? You want to do the hand soap?
Sure.
Okay. So she's gonna pour hand soap. Why don't you put it in the one right next there? You can put the spoon on the table. And go ahead and just dump. And if you see that, it's a little bit different. There wasn't a huge color change one way or the other.
Mm-hmm.
Okay. Al, before we dump it in there, I'm going to get this bottle. Okay. So one of the things we're going to dump in is a solution that's made of drain cleaner. And it says lye, crystal lye drain opener. And you're going to see me use this again for another demonstration for equilibrium in a second here. And the active ingredient is 100% sodium hydroxide. That should ring a bell from part 1 of the video. So because I didn't want to have a chance of making a boo-boo on camera of spilling any of the solid, we already mixed the sodium hydroxide with some water. So Al, if you would pour very carefully into this one. And just go for it, kid. Well, that's interesting. That went straight green.
Yeah.
You know what? Let's have a little bit of fun. Let's add a little bit of solid in there and see what happens. You can actually see it at the bottom. It's actually starting to turn yellow. So let's leave it sit there. And the last one we're going to do is 2% milk. So before we mix that together, make a prediction in your head. Do you mind if I pour this one?
Sure.
Okay. If you think this is going to be acidic or basic?
That's an ugly color.
Which one? This one? Yeah, guys, look at it. As it's sitting on camera, you'll notice it's changing.
It's got like a cloudish thing coming up.
Here we go with the milk. And let's take a spoon and give it a little mixy mix. You'll notice, when I get the spoon out of the way, one thing should be apparent. So A, it's not clumping up, so you are getting a solution. B, it's not going blue. It's certainly not green or yellow. So the old wives' tale you guys were given about, hey, if you ever drink too much acid, drink milk to coat your stomach and neutralize it, is not true. If anything, it's neutral. And depending on how you make it out, it's even maybe a little bit light purple, like almost like a pH of 6 where it's gone down a little bit. Now, some of that might just be diluting the color that's there, but it certainly did not change colors to blue or green. So this tells you that milk is not basic. Keep that in mind, okay? Well, let's have a little bit of fun with some of the stuff that we have left. So let's just push these to the side for a second, out of the way. Oh, by the way, guys, so that lye that I added there at the end, look at how yellow that is. I mean, that's a pH of almost like 13, 14. So when I dispose of this down my sink here in a little bit, this is why it's a drain cleaner. A, it's perfectly safe to dump down the drain because it's used to unclog drains, and B, be careful. Okay, so we got these out of the way. So we've got a little bit of indicator, and I've got a whole other bottle of this stuff in my fridge. So we might as well go to town. So, Al, if you would very kindly put just a teensy bit of the solid in there. Yeah, go for it. That's good. And use that spoon to mix it around. Oh, so she barely had any on her spoon, and look at what happened. She went green already. Well, let's see if we can't pull this back a little bit. So keep that spoon. We're going to use it to mix. Mix it. Oh, we got our purple back. Let's see if we can't go the other way now. Stop mixing for a second. Let me get in here. Well, you know what? Since you haven't drank out of it yet, kid, we'll borrow a little of your soda.
That's really bad.
That's high quality stuff right there. Do you want to pull it back so it's blue again?
Sure.
Let me get the ammonia. Guys, we could do this all day long, okay? So think about what's going on here. From purple to green to pink, back to green. We could keep playing with the color as long as we're playing with the amount of acid, H+, that we're adding. We can mess with this color change all day long. When I do another video on acids and bases, we're going to do something called a titration, where you neutralize on purpose the amount of acid or base you have, where you take an unknown amount of acid and neutralize it with a known amount of base, or vice versa, and you can start making predictions about what kind of solutions you're dealing with. So part 2 will be coming in a little bit. We're going to have to do it with some medicine droppers. We'll catch you later. Allison, anything you want to say to the kids?
Smells really bad.
Smells really bad? Guys, waft. Remember, waft. See you next time. Allison, say bye. Adios.